Starting at Unit 7, we are going to be simplifying radicals. When we say the word radical in kind of math terms, we're talking about square roots. And if you remember from, whenever you learned what a square root was, you know that when we talk about square roots, we're looking for a number that when multiplied by itself gives you the number we take the square root of. So here is a table of some common ones, all the ones from 1 to 20. And you can see that the square root of 1 equals 1 because 1 times 1 is 1. And so on for the rest. The square root of 4 is 2 because 2 times 2 is 4. It's the opposite of the second power. I'm kind of going backwards through that. So all the way up to 20 because 20 squared is 400. We're also adding in the imaginary number I, where the square root of negative 1 equals I. Because if you think about it, normally you can't have a negative square root, because let's say we have the number 3 times itself, that gives you 9. Negative 3 times itself also gives you 9. There's really no way to get to a negative number when you multiply a regular integer by itself. So we have this made-up thing, the imaginary number I, where the square root of negative 1 equals I, and so I squared also equals negative 1. Regardless, you can use this table to reference as you work through, or just use a calculator and it can help you out as well. In essence, though, we have the basics of a square root. If a squared equals b, then a is the square root of b. And just some vocab here. The radical sign, this is what the square root sign is. It's called the radical. And whatever's inside is known as the radicand. If you have powers inside your radical symbol, the way we evaluate those square roots is by dividing exponents by 2. And now remainders are going to stay inside the radical. So anything you have left over after taking the square root is going to stay inside the radical, and you'll see what that looks like when we do some examples here. All right, so let's look at example 1.1. We have plus and minus the square root of 100. So this plus and minus just means positive and negative. So we're looking for the positive and negative square roots of 100. Well, the square root of 100 is just 10, and so we'll stick that positive negative symbol out front, and that's good to go there. Whenever you have a fraction like this, as long as you can evaluate the square root of the top and the bottom, you don't really need to worry about the fact that it's a fraction. So the square root of 36 is 6. The square root of 49 is 7. And don't forget that negative sign out front. For number 3, we have a negative inside the radical. And this is where we're going to end up with an I in our answer, because the square root of negative 1 is I. So we can think of this in a few ways. Let's break it up here into perfect squares and whatever's left over. So the negative sign, I'll make that a negative 1 so we can really see where that I comes from. The 121 is a perfect square, so I'll leave that alone. Now for y to the 7th, an exponent has to be an even number to be a perfect square. So the biggest even number, less than 7, is 6. And then there's 1 left over. And so I haven't changed anything. I've just kind of broken it down into things we can take the square root of. So now to get the final answer, just go through and take the square root of each of these things separately. I like to start with the number 121. The square root of 121 is 11. The square root of y to the 6th, just divided by 2, is y to the 3rd. The square root of negative 1 is I. And then left over inside the radical is just that y by itself. So everything else was a square root. The negative 1 gave us the I. The 121 gave us the 11. Y to the 6th gave us y to the 3rd. This y stays inside. And there's the final answer right there. Let's look at number 4. Number 4 says the square root of 72. And we have to think of a perfect square factor of 72 because 72 itself is not a perfect square, but it does have perfect square factors. And you want to think of the biggest perfect square that goes into 72. So just as an example, we can list out some factors of 72, like 1 in 72, 2 in 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9, and I think that's it. But now out of all these factor pairs, only 2 of them have perfect squares, but of those 2, 36 is the biggest one. So that's the one we want to use. So we can express 72 as a product of 2 and 36, and that will allow us to take the square root of just a part of this. So we know the square root of 36 is 6, and that 2 is going to stay behind inside the radical. So what you're going to be looking for is the biggest perfect square factor of your number, if it's not a perfect square itself, to take the square root of and simplify your radical. Number 5 is 52. Similar idea, we're going to find the biggest perfect square inside of 52. And that is 4. So 52 is 4 times 13. Obviously 13 is prime, so it doesn't have any factors itself. So the square root of 4 is 2, and the 13 stays inside. Now number 6 already has a number out in front of it. That's okay. Whenever we simplify the 27, we'll just multiply whatever we get by 6. (27) does have a perfect square factor, which is 9. 27 is 9 times 3. So the square root of 9 is 3. And we're going to multiply that by the 6 out front. So we get 18 square root of 3 because this 3 stays inside the radical. On number 3, we have another negative inside. So we're going to have I in our answer. So this is 3 times the square root of negative 16. 16 is a perfect square, so the square root of negative 16 is 4i, the I coming from the negative sign. And 3 times 4i is just 12i. And that's the answer on number 7. Number 8 says 2 times the square root of 150 x to the 5th. So we have to think about 150. Well, I know that 25 goes into 150 6 times. So 25 times 6. I also know that x to the 5th is an odd number. The biggest even number, though, is 4. And then we'll have 1 left over. The biggest even number less than 5, that is. So now we can go through and simplify this. The 25 is going to give us a 5. And the x to the 4th is going to give us an x squared. And everything else will stay inside the radical. And don't forget, there is a 2 out front, so it needs to get multiplied by 2. So 5 times 2 is 10, and the x squared is there as well. And left inside the radical is the 6 and the x, so 6x. So everything we take the square root of comes outside the radical and goes in front, and everything else stays inside. Number 9, we have a to the 4th, b to the 10th. Now these exponents are both even, so we can just take the square roots by dividing those by 2. So we get a to the 2nd power and b to the 5th power. For number 10, again, we have a negative in the radical, so we will get I in our final answer. Everything else inside is a perfect square, though, so we can just go right down the line. Square root of 25 is 5. Square root of x to the 6th is x to the 3rd. Square root of y to the 12th is y to the 6th. Square root of z squared is z. And then the negative sign out front gives us an I for our answer. Number 11. So consider each thing separately, right? 2 is not a perfect square. But x to the 7th, we can write that as x to the 6th times x. And y to the 9th is y to the 8th times y. And so those two things we can pull out as square roots, x to the 6th and x to the 8th. So that's x to the 3rd and y to the 4th, and everything else stays inside, 2xy. Number 12, we have 45, a to the 4th, b to the 5th, c to the 6th. Well, 45 is not a perfect square, but it can be written as 9 times 5. A to the 4th is fine. B to the 5th should be written as b to the 4th times b, and c to the 6th is okay too. So the square root of 9 is 3. A to the 4th becomes a squared, b to the 4th becomes b squared, and c to the 6th becomes c to the 3rd. And then what's left over is the 5 that we didn't use and the b that we didn't use. So take the square root of what you can. Everything else stays under the radical symbol. There is another kind of rule here, is that when you have a fraction, you don't want to leave a radical symbol in the denominator. And to get rid of that, we multiply by what's called the conjugate of the denominator. In this case, since these are fairly simple ones, it's just going to be the same as the denominator. But basically, when you multiply it together, it's going to cancel out the square root symbol. So we're going to multiply here, since square root of 5 is on the bottom, by the square root of 5 over the square root of 5. And what that will give us is the square root of 60 on top, 12 times 5 is 60, and the square root of 25 on the bottom. Well, the square root of 25 is just 5. And so you can see that multiplying by the square root of 5 here essentially just takes out the square root symbol. And so you're back to 5. And now 60 can be written as 4 times 15, because 4 is a perfect square. And so this is, the simplest form is 2 times the square root of 15 all over 5. And this is a nicer fraction because it doesn't have the radical symbol in the denominator. All right, number 14, same idea. Multiply by what's on the denominator, square root of 3 over the square root of 3. The reason why we also multiply the numerator is because we want to not change the value of the fraction. And so we multiply by a fraction that's the same on the top and the bottom because it is equal to 1 and doesn't actually change the value of this fraction. It just changes the way it looks. So here we get square root of 24 over 3, because again, those square roots cancel out because we multiply by that conjugate. And 24 can be written as 4 times 6, again using 4 for that perfect square. So this is 2 square root of 6 all over 3, and that's the answer there. For number 15, we'll multiply by square root of 2 over the square root of 2. So we get the square root of 30 all over 2. And 30 actually has no perfect square factors. So that's all we can do. Okay, last one. Square root of 5 over square root of 15. I'm actually going to consider this as one big fraction like this, which is the same thing. But that lets me reduce that 5/15 to 1/3. And now when I multiply by square root of 3 over the square root of 3, what I end up with is just the square root of 3 over 3, and that's our final answer. Okay, so when you have a radical in the denominator, make sure you multiply by a fraction that will cancel it out. Use what is in the denominator and multiply by the same square root. And as for simplifying these, you want to find the biggest square root factor you can pull out of that number. And then for exponents, just divide by 2.